Tekla Structures Masonry Tools, Lesson 5, Practical Application with Columns, Pilasters, and Curved Walls. Topics in Lesson 5 include techniques for creation of masonry columns, approaches for the creation of bonded and unbonded pilasters, and the creation of curved masonry walls. In this section of our lesson, we're going to create some columns and pilasters. Now, naturally, these features are very similar in construction and will share some of the same modeling techniques. To begin, we're going to be using the view elevation on grid B along with our 3D view. You can close any other views that you may have open. And once these two views are open, go up to the top right to the window drop-down and select Tile vertically, as shown on screen. Note that whichever view you have active is going to be the one placed to the left-hand side. First, let's start out with creating just a basic column. We're going to place it centered at the intersections of grid lines 2 and B. We'll use the CMU block tool from the Applications and Components pane and load up our save setting for a full block, which we named ts_cmu_reg_full. Before we apply and place the block, let's go ahead and change the name to be column and the design name to be COL. Once you do so, click the Apply button to apply the settings, and then we can place the block. We'll go ahead and place the block centered on 2-line, and then once we do, we can nudge it into position. In the 3D view, let's move the block in the x-axis so that the left edge is along grid line 2. Also, let's move it downward or negative in the y-axis so that the center point of the long edge is also centered on B line. Lastly, in the elevated view, let's go ahead and move the block upwards so that the bottom of it sits on elevation 0. Now that we have our block in place, we're going to go ahead and add our 12-inch block to the right of it. We'll actually use this one and select it, right-click and choose Copy, and then snap towards the right and click in the value of 12 inches. Once we've done so, we can double-click on the second block and change the shape using the Shape Catalog to CMU-12 by 8 by 16, as shown. And it seems we're going to have to nudge this back an additional 2 inches so that we maintain our 3/8 inch mortar joint. Lastly, let's move these two blocks, or our first course of our column, 9 and 13/16 to the left or negative x-axis, so that the course is centered at the intersection of column lines 2 and B. As stated, these two blocks form the extent of our first course, and now we can copy them upwards in the z-axis 8 inches to establish our second. Once we do, we'll need to rotate these blocks 180 degrees. We can select both of them and then right-click and choose Move Rotate. We need to make sure that the angle of rotation is set to 180 degrees and that the Around drop-down is set to the z-axis. For our rotation point, we can select the intersection of column lines 2 and B. If you're having trouble selecting this, ensure that you have Snap to Points and Grid Intersections turned on in the snapping toolbar. You can also turn your blocks transparent by using Shift-2 and then snap directly through the blocks themselves to the grid lines. Ensure that you are selecting these blocks in the second course and then click Rotate. This will provide us with our bonded pattern. Creating the rest of the column is easy, and we just simply need to copy these courses upwards in the z-axis 16 inches. We can use the Copy Special linear command to do this, and we'll just change the number of copies at the top right to 6. And here we have our basic column. Once you have your column established, it's pretty easy to copy it in place wherever the configuration is required. So the upfront time in creating it goes a long way. However, in the case that these blocks would need to be cut in the center to form a hollow core, the process remains the same, except once we place the first course, we'd cut the blocks with the Polygon Cut tool before proceeding. So let's practice this and go ahead and select the first two courses from our column and copy them from grid line B to grid line C as shown on screen. Now, you could just copy the first course instead. It's up to preference if you would prefer to do 4 cuts on 4 blocks or do 2 cuts on 2 blocks and then copy and rotate to get your second course. Whichever method you prefer is perfectly valid. But once we've copied, let's go ahead and close the Elevation on Grid B view and then open up the view Elevation on Grid C and then tile them vertically as we did previously. Now, I prefer to model only one course and then copy it up and rotate, so I will delete the second course we just copied over. Again, this is up to preference. If you choose to keep the second course, you can always get it temporarily out of your way by selecting the two blocks, right-clicking, then press and hold Shift on your keyboard, and then select Hide. This will hide the blocks as well as any small lines that are used to represent its location. Now, let's go to the Edit ribbon and choose Polygon Cut, and we're going to start cutting our 12-inch block on the first course. Just trace the inside edges of the block to start establishing the polygon. Keep in mind you don't have to trace the entire radius of the corner with many little lines, you can just snap to the endpoints of the arc as shown to avoid it. The only other thing to keep in mind is that you want to snap to the inside of the block wall on faces in which you want to keep, and you want to snap to the outside of them for the ones you want to remove. You can even go so far as to use the face of the other block as shown on screen to ensure that you don't misclick and get any elements of the block face that remain after the cut is applied. Once you complete the polygon, the block is now cut. Now, all we need to do is repeat this for the 8-inch block. Then we can copy the course upwards 8 inches, rotate it 180 degrees, and then copy the two courses upwards 6 times, just as we did before. So let's go ahead and complete the remainder of these tasks to complete our column. Now, with columns such as these, often you're going to need to account for the reinforcement inside. We can apply reinforcement to the column blocks, but it gets a little tricky. One trick that we could use is to actually model the grout inside the column and apply the reinforcement to that. Now, typically we don't model the grout or mortar for masonry in Tekla, as that require way too many cuts in the model for accuracy's sake. But in the case of these columns or even some pilasters, if we do model it, it really does expedite placing the reinforcement. So we'll do this on the column with the hollow core, as it makes the most sense. But you could even do this on our first column with the blocks whole and use it for placing your corner bars. So let's go up to the concrete ribbon and then we're going to choose the column tool. Now we're going to go over to the properties pane and we're going to change a couple of things. We're going to change the name to column grout. And we're going to change the material to grout as well, which can be found under the concrete drop-down in the material catalog. We're going to change the profile so that the grout stays within the walls of our CMU column. We're also going to adjust the top and bottom elevations for our grout column to match the CMU column. In this case, 10 feet 7 5/8 inch for the top and 0 inches for the bottom. And then we're going to click the intersection at 2 and C to place the column. Now that the grout has been established, we can use the rectangular column reinforcement, number 83, to populate the bar that we need. We're not going to cover all the particulars of this component in these lessons, but documentation is available on the component in the TUA. You can quickly access it from the Components dialog box by clicking the Help button at the top right. The point here is to adjust the dialog settings for the reinforcement to reflect your bar configuration and then apply and click the grout column to populate. Now you have a reinforced column. The same approach can be used to populate reinforcement with other tools such as rebar sets found on the concrete ribbon. Keep in mind, tutorials for rebar sets can be found under the tutorial section of the Tekla User Assistance webpage. Once we've finished with the column, we can go ahead now and copy all of those objects upwards to the intersection of D line and 2. Pilasters are very similar to columns in regards to modeling techniques. If a pilaster is unbonded, then creating one is pretty much the exact same process as the first column we created in this lesson. The only difference being is you'll have to align one edge with the walls on either side of the pilaster and ensure that the wall's start and/or end points on either side maintain the appropriate joint gap. It's relatively straightforward, so let's go ahead and execute that now. Please go ahead and copy the column at the intersections of grid lines 2 and B, and place it as shown so that it is an unbonded pilaster for both walls on lines 1 and 3 at the intersection of grid line C. Make sure to adjust the start and end points for the wall's 1/2 block's length away from the seam so that it can accommodate the pilaster. Next, copy the column from B and 2 and align it with the walls. Make sure to adjust the properties of the block so the name is pilaster and the design name is unique, such as PIL. You may also want to make the blocks visually distinct, and if so, just change the class of the pilaster blocks. A bonded pilaster isn't much different, but there are some things to consider. First, you should place the wall that contains the pilaster first using the CMU wall tool. To proceed, we'll be utilizing both our 3D view as well as elevation on grid B. Our pilaster will use both 8-inch and 12-inch blocks, same as our columns, but this method will work with other configurations as well. Considering we want these changes to be permanent and that we finalize the other criteria of our wall, it's reasonably safe to explode this wall to avoid overwriting changes that we're about to make, including our pilaster. So let's go ahead and select the wall, right-click, and then select Explode Component. On the first course, we're going to replace the 8-inch block placed by the wall tool with a 12-inch one. We will do this on the wall that's located on line 1, specifically at the intersection of 1 and B, and we're going to make sure we maintain a 3/8-inch mortar gap. Then, going upward, we will do the same for every odd number course. The reason for deleting, as opposed to changing the shape, is that we want the attributes to be populated with up-to-date and correct information relating to our pilaster. So in this case, we will choose to replace the block instead of editing it. For the 12-inch block, we can start with our TS_CMU_reg_full setting, and let's go ahead and change the shape to a CMU-12 by 8 by 16. We'll also change the class to 21 and the name to pilaster. And then lastly, let's also adjust the design name to have PIL. So let's go ahead and place our 12-inch block on the first course and align it as shown on screen. Here, I'm going to hold down Control before clicking and then key in 3/8 of an inch to give me a starting point, and then click the second point for my block. After which, I will adjust the block's position vertically. After we replace the 8-inch block with the 12-inch one, we will need to add another 8-inch block to the right of that as shown on screen. We can just copy our 12-inch block directly to the right and then change its size to an 8-inch unit, and make sure that our gap remains at 3/8 of an inch. On the second course, we are going to place a 12-inch block against the two 8-inch blocks of our wall, so that it is centered at the mortar gap. Once we have our first two courses configured and the 8-inch blocks in the wall deleted at every odd course directly above, we can select our pilaster blocks and use Copy Linear to populate the two courses 6 more times at 16-inch intervals vertically. And with that, we have a bonded pilaster. It's important to note that some specialty or uncommon block shapes may be used in cases with columns and pilasters. Although Tekla's Shape Catalog does not provide these specialty shapes by default, it is a topic that we are going to be covering at the end of these lessons. For now, let's go ahead and repeat the process so that we have bonded pilasters at grid intersections B1, B3, D1, and D3. For this last portion, we will cover a method used to create curved walls with masonry units. Now, depending on the size of block being used, the minimum radius in which the curve can be applied changes. For our specific example, we will ultimately end up using 4-inch masonry units, and therefore our minimum radius will be 19 feet 6 inches. For this example, we will work in the 3D view, and we will be creating our curved wall to the right of grid line 3. So first, go to the View ribbon and select Work Area, using 2 points, and define the work area so that it contains an extra space to the right side of our second building, as shown. Next, let's place some construction lines to help guide us. We'll use the very end of grid line A on the right-hand side for our starting point, and snap directly to the right and key in our minimum radius of 19 foot 6. We'll use the same starting point and repeat, but this time we'll create a vertical line also for 19 foot 6 inches. It's not necessary, but if you wish, you can also add a construction arc as well. Go to the Edit ribbon and then Construction Object and select Arc from the drop-down. Then choose the 3 points, just as we placed our construction lines. Now we will use the CMU block tool to place a singular block. We can use our TS_CMU_REG_full preset to start. After placing, let's align the block so that its left center face falls at the end of our 19 foot 6 construction line. And we can also adjust its vertical position so that the bottom of the block is on elevation 0, as shown. We will now use the radial array component, which you can find by searching Array in the Applications and Components side pane. Let's go ahead and double-click on the radial array icon to bring up the dialog box so we may specify our criteria. This tool will allow us to populate blocks in a similar way to our copy linear tool, but will also add the bonus of specifying a radius to apply this array. Let's go ahead and change the drop-down that contains the word angle and choose distance. The text field at the very bottom of the dialog box is related to the angled dimension in the image, and this is where we populate the radius of which the objects will be arrayed. So we will populate this field with 19 foot 6. In the fields below distance, we need to provide the distance we need to array. So in this case, our block length plus the mortar joint. So we'll start with 16 inches. And then the number of copies to array. So we'll start with 24. Below that, we can change how the array is going to be applied in relation to our original object. And there are a few options, but we want to keep ours set to normal. Feel free to experiment with these other options at a later time. Now, once we've made our changes, let's hit the Apply button. Now, we must pick our 3 points. It's the same 3 points that we used to apply our construction arc and apply our construction lines. The vertex is at the intersection of our 2 construction lines at the end of grid line A. Then we will proceed to pick the second point perpendicularly 19 foot 6 to the right, and then the second point, again 19 foot 6 to the above or positive y axis. Once we do this, the component will apply the radial array to the block. It seems we have one extra block at the top, so we can change the number from 24 to 23, and then selecting the arrayed blocks, hit Modify to adjust. Now that we have our first course, let's change our block size and then copy our courses upwards. Let's double-click on the original block that we placed with the block tool and change its profile to CMU-4 by 8 by 16. Notice that since we changed this one block, all the blocks in the array have been updated. Now that we've done that, let's go ahead and nudge our original block back so that its left center face sits at 19 foot 6 from our radii center point. Now, before we go any further, we should make sure to check that our mortar joints are correct. We're going to need 1/8 inch on the inside of the blocks, but no more than 3/8 inch on the outside. And using the measure tool, it seems we are a bit too big on both sides. It's easy to fix. All we need to do is double-click the blocks that are in the array to bring up the dialog box, and we'll adjust our 1 foot 4 inch array distance to be reduced by 3/8 of an inch, and then apply. We can use the measure tool again to double-check. As we can see, it's now correct, 1/8 inch on the left and 3/8 inch on the right. Now, we can form our additional courses as we have been in the past. We can copy the original block upwards 8 inches and notice how the array also comes with it. Next, let's rotate the second course so the bond sits correctly. Now, we can use the Measure Angle tool to get the angle of rotation we're going to need. And once we have that, we can use the Move Rotate command with that angle to nudge the second course a half block's length in the counterclockwise direction. Next, select the block, right-click, and then choose Move Special Rotate, And from here, we can populate our rotation point at the intersection of our construction line and place our angle we've just measured, 1.92753, in the angle field, and then hit move. From here, we can add 4-inch half blocks at the end of our two courses, and then we can copy the two courses upwards in the z-axis 8 inches a number of times to reach our desired height. And now we have a basic curved wall. You can integrate these walls perpendicularly to straight walls by using the same steps we did to add bonded or unbonded pilasters. So although with curved walls we're using the radial array component, you can see that the process still remains relatively similar to the walls, columns, and pilasters that we've already created, using a combination of placing the blocks and moving and/or copying them as needed. This concludes our lesson. Proceed to the next lesson, Lesson 6, Phases, Tagging, and Filtering.